Standing here with Henri Bal, Professor of Computer Science. Professor, we hear now the economists, the biologists, they're all talking now about complexity theory, they're talking about big data, they're talking about networking. So everything you did 30 years ago, they're now doing. What does that mean for practical implementations? What should happen next for them?
I think what should happen next is to find the commonalities among all those fields and to work on common toolboxes, so pieces of software that you can share between communities. I'm not claiming that you can come up with software that works for everybody, but there certainly should be toolboxes that can be shared between multiple communities.
So you're saying if you have 10,000 financial institutions or 10,000 cells, or you have, on the other hand, some computer problem, they need the same. They have the same problems and they need the same analysis tools, and and everybody's building their own.
Yeah, so that's a problem. Many people are reinventing the wheel, developing software from scratch and wasting time debugging it and optimizing it. And what you need is a common software base that professional people use and maintain and optimize. And then it's used by biologists and by economists and others. And that's far more efficient.
Did you ever think that this whole network thinking, which is in our head completely normal, that these guys would come up, that we're so enthusiastic about that?
No, yeah, it's amazing. Yeah, so it all seems to evolve around networks, but for networks you can certainly develop common toolboxes. So it's graphs and optimization problems, pathfinding,
data analysis. But are you amazed? When did you first see that colleagues of yours in different industries were just starting to talk the same language that you are already doing for 30 years?
Yeah, that's fairly recent. I'm fairly new to the complexity world, actually. I had a colleague at the VU, Maarten van Steen, who was one of the first who started talking in our department about it. So then I got really enthusiastic about this.
Amazing. So this is bridging gaps. Now, we have 20 million to spend on complexity theory. How would you spend it? Would you make small teams, big teams? Would you have huge big software developing processes or small ones? How would you spend the money?
I agree with one of the other speakers. We should not build gigantically big teams.
How big can the team be?
I like the Einstein model, so between 3 and 7, I would say. That sounds good.
And how much money per team?
Yeah, per team you need let's say 500,000, on that order of magnitude. It's a couple of people funded. And the software should also not be gigantic. We've seen examples like grids, well, they were way too complicated. So what we need is simple tools, like simple pieces of software that people can understand, that you can show works correct, and then share it by multiple people.
Now, the way we have now funding in this country, will this obey those laws?
No, because the problem is it's all multidisciplinary. So you would need a funding scheme that will satisfy the economy reviewers and the biology reviewers. The NWO doesn't have committees yet.
Yeah, and you need models for different kind of universities to working together with different kind of fields. And so they need 10 million to even coordinate among themselves.
Yeah, exactly. Now the funding scheme, they have to change. It really has to become multidisciplinary.
You can write a nice website for that?
Certainly.
Thank you very much, Professor Bali.